From the beginning it seemed I was going to be heading to sea as a young boy growing up. Miami in the 1950s, the boating capital of the world at the time. I was that kid on the dock that would do just about anything for a ride on a boat, so I did a lot of washdowns and cleaning, and I did get that first ride on a 50-wheeler sport fish. That ride hooked me for life. It seems the only thing after that ride I wanted to do was anything having to do with boats. I started drawing them, then building models of boats. I had boats on my mind 24/7, and as a young boy the only thing I ever dreamed of was one day heading out to sea on my own boat, as I did in my later years on my sailboat the Lady in the 1970s. In 1961 I was drafted into the Army and served for years, honorably discharged in 1965. First job after the Army was with a company on the Miami River, a marine research company that had a contract with the US Navy testing new weapon systems, mostly torpedoes. I was hired as second mate and helmsman position on a 121 TRB off Andrews Island, Bahamas. After Mars I went into yachting, first as a first mate on a 118 Fed ship, then onto other yachts as master on yachts from 50 to 160. I worked mostly in the yacht delivery business as I wanted to be at sea as much as possible. One of the issues working as a yacht skipper was most yachts did not move around much, mostly only used a few months out of the year. The rest of the time you were just setting under a boatyard shed, and I wanted to be at sea running them, not setting under a shed, so yacht delivery work fulfilled my need to be at sea. Plus I just really enjoyed running boats, power or sail. Also in the 1970s I went sailing off for about 5 years, sailing the Bahamas, the Caribbean, into the Pacific to Hawaii. I would have to say it was some of the best years of my life, waking up to a beautiful sunrise, then jumping in the water for dinner, then would come a beautiful sunset. On one of my last sailing trips I met my lady, and it was time to move ashore as we had our first son Alex, born in 1983, and time for a new occupation. I went into marine contracting, doing yacht refinishing and fabrication of custom marine products such as tackle centers, helm stations, and boat building. In the mid-1980s we were living in Stuart, Florida, and I was doing a yacht refinishing job on a sport fish, and the owner had a big problem with the boat's exhaust noise, and it's how I got into the marine exhaust business. The boat was built with a straight pipe system, no mufflers, as a lot of boats back then were built this way. The exhaust sound on the flybridge was over 115 decibels. The owner asked me if I had any ideas to fix his sound issues. There was no room for mufflers, so I designed an outside platform exhaust design that was both an exhaust system as well as a high-speed backdown system. It all worked so well, taking the sound from 115 decibels to 80 decibels, a drop of 35 decibels, plus the boat could back down at over 14 knots without taking water over the transom. It worked so well the owner of the boat started a company under the name Delta Aeroflow, but the partnership did not work out. Even though the partnership did not work out, the design worked and created much excitement within the marine community. After Delta I was asked to design and build a 77-motor yacht, where I took the exhaust design to the next level by designing the exhaust into the hull design, as well as several other design ideas in hull design, such as a self-planning hull design that proved to be very successful, putting the hull on plan at low RPM speeds. It was a great R&D project, being able to put some of my ideas to practical use. After this I went back into marine contracting, opening up a boat shop in Clearwater, Florida, once more doing marine fabrication and boat building, as well as a new exhaust company under the name CMI. The exhaust design was once again refined in 1995. The design was shown at the Chicago Marine Intake Show and was one of the runners-up for Innovative Award in 1995. In late 1990 a new company was formed under the name EcoSound, where we did extensive testing on 17 hull designs. This time it was I was designing it into not just an exhaust system but a hull performance system. The new design was the first underwater exhaust using a vacuum wedge. The systems were all extremely quiet, plus the real benefit was faster planning speeds and top-end speeds, but the real benefit was 15 to as much as 20% better hull performance. The first OEM was Sea Ray Boston Whaler on a new 34 boat that proved the performance benefits. Without the design the boat lost 3 knots at top end and took 50% longer getting on plan, once more proving the performance advantages of using this system. The only problem was it was still an outside system that it seemed the OEM market had little interest in, but we did well over 100 retrofit hulls from the smallest at 25 to over 130. But the design, as good as it was, even with customer letters that raved about the benefits of this design, we had little interest from the OEM market for the design, so I designed an inside-aft chamber design. First boat was also retrofit a 60 Bertram Sport Fish, the Blue Heaven. The boat had a number of exhaust issues, mostly due to excessive back pressure. We were recommended by Tim Cheffant, head of engineering at Bertram Yachts. The boat was being repowered with the new MTU 12V 2000 series. Also at the same time, we were also designing one of our first stringer system exhaust designs on a new 105 Broward Sport Fish yacht, both of which used our new adjustable wedge system where we could adjust back pressure. At sea trial, both boats was a great success. The 60 Bertram, we set back pressure and zero throughout the full RPM range. We did the same on the 105 Broward, but MTU on the Broward wanted 15 inches of water at wide open throttle, and due to the adjustable wedge system we were able to adjust the back pressure at 15 inches of water, just where MTU wanted it. Both applications were very quiet, below ambient water noise throughout the full RPM range. With the success of both boats, the news was getting around a new exhaust design was an alternative to the traditional pipe system. In 2001 we started signing up some of our first OEM builders, Paul Spencer, then Donzi Roscioli Yachts, then Jarrett Bay, and more builders was starting to understand the benefits of this new exhaust design. The one company that we worked with as almost a partnership was Donzi Roscioli. After the first few boats, Bob Roscioli was totally sold on the system, and we became standard on all his boats from the 58 to the 86 Donzi. One of the big benefits of our stringer system was more room for fuel, as other things was getting in the way, more equipment such as seakeepers, ice makers. One of the first engineers that recognized the overall benefits of the stringer system, Tim Chalfant of Bertram Yachts, he said, "Today in boat building it's like trying to put 10 pounds of potatoes into a 5-pound sack. With more horsepower we need more fuel, plus now with new things coming into the market that every boat owner wants, real estate aboard is becoming one of the big issues in future of boat building." The stringer system was designed to maximize space, as it has done for the builders that has used our stringer design. Shortly after our success on the Broward 105 and the 60 Bertram with MTU power in 2001, I met Paul Spencer at the Miami Boat Show. He said, "I believe it would work." Paul was interested in the design, and he said, "I want to try it on my new boat, the Sizzler, that was going to have the new Cat C32 at 1550 HP. In that conversation, Paul said, "You will be taking a chance with this boat, as I know you are trying to break into the sport fish market." He said, "This is going to be my personal boat, and it's going to be doing the tournament circuit. If we don't catch fish, you know what they are going to say, the underwater exhaust is creating too much whitewater or something." I said, "Fine, it's not an issue, it won't scare fish away." And we designed an aft chamber system, my son Alex and I did the sea trial. The boat made 47 knots. Paul was happy with the outcome. He did say the boat had a little more bow down at above 40 knots, but said he knew how to fix that issue on the next boat, and it is true. It seems our wedge has about a 1 to 1.5 degree lift at above 40 knots. To correct this, it just changing the CG, not a big issue. Most any naval architect can tell you what to do, easy fix. But the interesting thing about this conversation, Paul's boat won about every tournament that year. In fact, when I met Paul at the Wanchess tournament, there was nothing but blue flags flying for him, both outrageous. He had a great winning year, so it was obvious our exhaust design didn't chase fish away. In fact, it was that same tournament when I met Mr. Ramsey of Jarrett Bay. He stopped me as I was walking by his booth. He said, "You are that new exhaust guy, right? You are on Paul's boat, right? That underwater exhaust." He handed me a card and said, "Come see me." Then saying it sure in the hell don't scare fish away. And soon we were doing exhaust systems for Jarrett Bay, and still are. With now two of the biggest sport fish builders in North Carolina now using our design, it got the notice of one of the biggest sport fish builders in the country, Viking Yachts in New Jersey. In 2005, Viking agreed to a shootout of our system and the exhaust design. They were using the marine exhaust Linea muffler on two identical boats, same power, 61 Viking with the Cat C32 Acer at 1650 HP. Our claims of lower back pressure, less heat and noise reduction, plus the elimination of steam and the station wagon effect of fumes within the cockpit area of the boat. The sea trial showed the clear difference of the two systems. The outcome of that sea trial, we became standard on most of the Viking models in production at that time, the 61, 68, 70, 76, and 80. Based on customer reviews, the owners were happy with the new exhaust. Most any skipper that has run a Viking with our system will tell you is of all the benefits, the best of all is after a day's run the cockpit is clean, no salty mist on that big back window. The system was nothing but a good move for Viking. After my success with both Caterpillar and MTU engines as well as MAN and Deutz engine companies, I felt it was time to go into the big yacht market with the MTU 4000 series and the Caterpillar 3400 series, and we had an interest from a builder in Mississippi, Trinity Yachts. They had a new build, a 167 fast motor yacht. The power was the new MTU 20V 4000 series at 5700 HP. One of the deciding factors of going with our design, as I said, we would increase the speed over what Trinity was traditionally using for their underwater exhaust. The Trinity had a performance speed is had to make at wide open throttle. The yacht had to make no less than 28 knots. Trinity tank testing our design in Germany. The tank testing showed an 11% improvements in hull efficiency using our design. I redesigned the entire exhaust system from the forward pipe entry to a totally new pipe design for faster cooling, as well as being able to take 100% of the exhaust cooling water, a total of 1,200 gallons permitted, and still remain within back pressure requirements of no more than 34 inches of water in back pressure. At sea trial, the yacht had no exhaust noise in all RPM ranges. As to speed, we not only made the needed 28 knots but exceeded it at wide open throttle at 31.4 knots. Two of the most noticeable things was there was no exhaust vibration throughout the full RPM range. Also, the absence of any heat at the exit point at the transom. By taking 100% of the raw water cooling, we were able to reduce exhaust exit heat to close to ambient water, and their temperature at the time was around 85 degrees. The difference between the ocean temperature and the engine exit exhaust temperature, it was almost non-measurable. One of Coast Guard personnel that was on board said, "Seems we don't have any heat signature out of the exhaust," telling me it was an issue with their new Sentinel class cutter that was being built next door by Bollinga Shipyard in Gulfport, about the same size and using the same power. He said, "You might want to tell them about this sea trial, they might have an interest," and I did contact both Bollinga as well as Coast Guard headquarters in Washington and Baltimore, giving them all the needed information as to this sea trial. At about the same time, we also started on a design project with Palmer Johnson Yachts in Wisconsin and England on their new 170 motor yachts, as well as a new 215 motor yacht using the MTU 4000 series. We did 3 170s and 1 215 with Palmer Johnson Yacht before they closed down. All 4 yachts were a great success. We fixed one of the biggest problems with the conventional underwater exhaust inductors. We eliminated the underwater drag that is needed to suck the exhaust out of the boat. The tank testing showed 11% also on the 4 hulls with Palmer Johnson by the elimination of underwater drag. But the biggest benefit was in the speed ranges, where yachts of this size operate at 90% of the time when range is needed, like transatlantic crossings. All 5 of these yachts had a top speed in the 30-knot range, but most all will be cruising at around 12 speed to 14 knots. And it's this speed range the needed suction from the underwater inductor no longer has the needed suction to pull the exhaust out. This becomes an even bigger problem when in bad weather, when more power is needed but headway is reduced. Now the exhaust is trying to push its way out, pressure increases, you start feeling exhaust chattering due to forward speed being reduced and loss of suction. And this is one of the biggest benefits of my design, something that has been overlooked by most. But if you are engineer on any of these type hulls and power, you understand the problem. With the success of the 5 hulls, I understood we could most definitely solve the problems on the new Coast Guard cutter Sentinel. As to the conversation I had with the Coast Guard lieutenant that was on the sea trial on the Trinity, in fact we did a total of 3 sea trials on T-061. Did take his advice and got in contact with U.S. Coast Guard in Washington that directed us the Coast Guard headquarters in Baltimore, where we had a meeting with Coast Guard Engineering Department and a few other military departments, including several 4-bar captains. And based on our meeting, everyone in the room seemed to agree our system would solve a number of problems presently with the Sentinel class. I had the opportunity to inspect one of the new Sentinel Coast Guard cutters in Key West, and having the opportunity so understood the problem plus a number of other issues that need fixing plus save a hell of a lot of hull maintenance. The exhaust design on the Sentinels is an equated, it takes up to much needed space plus additional tonnage. The mufflers are as large as the main engines, hanging overhead at a terrible waste of space plus adding a lot of unnecessary tonnage at a high CG point on the hull. And based on a conversation I had with the crew, one of the most needed things needed is more space. Based on my most recent phone call, we are still under review since our last meeting. One of the things I was aware of on all 5 hulls was the absence of any heat throughout the exhaust system. The new pipe design was designed to do 2 things: 1, create faster exhaust flow as well as rapid cooling, and our ability to take 100% of the raw water cooling, not diverting any of the cooling water but sending all the water through the exhaust duct. And during all the sea trials the back pressure was very low. My question was, could we cool the exhaust down even lower by adding additional cooling water? Could we take all the raw water cooling from the engine plus introduce additional cooling water by the use of pumps? We had the opportunity to find out on the 140 motor yacht Serenity Power, the Caterpillar C32 Acer at 1950 HP. We installed a pump that would add an additional 150 gallons of outside ocean cooling water, giving a total of 310 GPM. The question was this: at normal cruising speed for this yacht was around 12 to 14 knots. How much of a drop in exit water temperature could we achieve by adding a number of spray nozzles downstream of the water can? At cruise speed of 1850 RPMs we had a heat reading of 160 degrees Fahrenheit without the spray nozzles in operation. When we turned on the spray nozzles and added the additional water, we had a drop in exhaust temperature within the pipe system to 90 degrees, a drop of 70 degrees, and engine back pressure dropped to 2 inches of water. Even with the additional water, back pressure continued to drop. We understood now it was possible to reduce engine exhaust water temperatures to close to outside ambient temperature. We understood we could add a lot more water and still remain well within engine company's back pressure requirements. This opened up a new possibility, not only to solve the heat signature issues on our military applications as well as an environmental impact if this technology was used worldwide in yacht and vessel construction using a wet exhaust system. With all that talk about ocean temperatures rising, it would have to help in a small way to reduce ocean temperatures. Based on all sea trial data on all 5 hulls Trinity and Palmer Johnson yachts, I understood we could add a tremendous amount of additional cooling water to almost eliminate any additional heat into the ocean environment plus eliminate the heat signature on military vessels using a wet exhaust system. Wet exhaust systems are the most used on 90% of vessels of this type in production today. We also know how to retrofit existing yachts. By the end of the last 5 projects with Trinity and Palmer Johnson yachts plus a number of large retrofit projects on several large ocean-fast yachts using MTU power, by the end of 2015 we had proven our exhaust technology on more than 100 large applications and certified by Lloyd's and ABS, several other marine agencies. The design passed all the engine company's requirements for back pressure and cylinder head temperature. The system proved to be quiet, and based on customer reviews from owners and skippers, the design lived up to all claims. It took me more than 30 years to develop this design. It was on the first sea trial on the yacht Blue Heaven with the first new application that I understood we had something much more than just an exhaust system. One of the biggest problems with all convention wet exhaust systems in keeping back pressure within the engine company's requirements was water was always an issue. Most all would divert the engine raw water to reduce the back pressure. The new MTU engine used more than twice the amount of water as other engines companies such as Caterpillar and MAN, and this was my first big engine application with them. 2000 series. I did not divert any raw water cooling. I sent 100% through the exhaust system what we could not send through the water can. The remaining amount of raw water was put back into the exhaust run just a few feet down the exhaust run. On that run, everyone on board noticed there was absolutely no steam plus no back pressure. Pressure dropped to under 0 inches of water. At wide open throttle we only reached 0 pressure. I quickly realized the overall benefit of this accomplishment by the elimination of steam. For was always the steam that would carry the exhaust mist back into the cockpit. The skipper was the one that remarked the back window had an absence of salt mist on the back windows after the run. I realized this exhaust design liked water, and the more water we pushed through the exhaust system, the lower the pressure would drop within the exhaust run. Once in a meeting with Riviera Yachts in Queensland, Australia, I had a meeting with the engineering department. They were interested in my system. Also in that meeting was another marine exhaust company. When I explained the benefits of my design, that we did not have to remove any exhaust cooling water from the exhaust and we could eliminate steam, the person that was representing the other exhaust company said, "Steam in the exhaust is our way of knowing the exhaust is being cooled properly." I could not believe he made that remark. Heat increases pressure and steam is an indication of heat. In the end, all the engineers agreed with my opinion on that subject and we got the contract. But it was on the Trinity Sea trial that I realized the real benefit, not only to the private yacht market but also to our military and our Coast Guard. But it was after my project on the yacht motor yacht Serenity that I understood the real benefits such a design would have as a military as well as an environmental impact. The overall benefits, especially in the Sentinel case, cannot be disputed. The saving its space can clearly be seen as it was in our meeting with the Coast Guard in Baltimore, Maryland. There was no gray areas. Everyone at that meeting understood the overall benefits. It was clear that this design would make the Sentinel class of better boat. We would eliminate the cost of maintenance of exhaust soot down the side of the hull, plus get more needed room and eliminating unnecessary tonnage, which would save overall fuel cost of the entire fleet. But the ability to lower exhaust water temperature to as close to ambient ocean temperature, that to me would be the ultimate benefit. But with all this said, why has not such technology not being used on all new vessel construction? Considering all the benefits in every meeting I've ever been to, including the meeting I had with the US Coast Guard in Baltimore, I've always asked, show me one negative issue with my system, and to this day no one has ever been able to find any negative issues with the design. The fact is, there is no better way to take care of the exhaust issues on private and military applications using a wet exhaust system. This design, it simply is superior to anything on the market today. It is not difficult to put it into production. In fact, it is easier to put into production than the conventional exhaust system that has fewer parts. It's much safer, quieter, and saves interior space and overall better for our oceans. At this time I will be resubmitting this to our United States Coast Guard and to large yacht markets. And after listening to this presentation, if you can find any negatives to this exhaust design, please forward them to me personally at vanwoodmandesign1.com. I will be soon posting a number of new presentations on both my website as well as my YouTube channel. For more information on my work and future updates, go to my website www.vanwoodmandesigns1.com. In my future presentations I will explain how this designs will benefit you as a boat builder in saving both labor and time on the production line and in building a better boat and giving the end user, the boat owner, the very best technology available today. Before ending, I would like to thank everyone that has helped me develop this design, that believed in my designs, such as Johan Hagstrom of Viking Marine Exhaust. Johan currently is my exclusive agent for the sales and manufacturing of my exhaust designs. We have worked together on most all my projects over the last 2 decades. Johan has a good knowledge of my work, and he is without a doubt a fine craftsman and stands behind his work. 844 471 461 for Johan at vikingmarinexhaust.com. Also, a very special thanks to Bob Rocholi for all his help over the years in believing in me and my design work. I sure miss him. He was a good friend. May he rest in peace. Never be another one like him. He built a great boat, and he was proud of his boats, as he should be. I have made this special message and sharing it today with all boat builders, naval architects, and engineers worldwide, plus several captains within the yachting industry, so that the word can be passed on to future projects. Look forward to your business in the future, and please feel free to contact me as to any questions you might have as to my work as it relates to this video presentation at vanwoodman@gmail.com. My next presentation will be the Riviera Story, one of the most innovative designs. Very good. Signing off. George von Woodman, President and Head of Design.